Hey there, welcome to my channel. Today I have something very special for you. I'm going to be giving you a summary of astrophysics for people in a hurry, asterisk, Neil deGrasse Tyson. This is one of my favorite books, and I will not do it justice by summarizing it. So I encourage you to get a copy and read it for yourself. But I can at least hit some of the highlights that really struck me as important. First, let's take a look at this beautiful picture of the Eagle Nebula and the pillars of creation. And let's just sit with that for a moment. The vastness of space and time, and our tiny little place in it. What is this thing? Where did it come from? Are we alone? These are the big questions that humanity has been asking for a long time. Astrophysics for people in a hurry, asterisk attempts to answer these questions. The book is divided into 3 sections: stars and planets, the Milky Way galaxy, and the big picture. Each section is broken down into digestible chunks with clear and concise language and lots of illustrations. It covers everything from the basics of gravity to the birth and death of stars, black holes, galaxies, and the universe itself. Now let's jump in and see what's inside. Part 1. Stars and Planets. Chapter 1. Gravity. We can measure how much gravity affects an object by weighing it. The more massive an object is, the stronger its gravitational pull. All objects attract all other objects in the universe, but the strength of that pull depends on their mass and the distance between them. As you increase the mass of an object, the force of gravity gets stronger. So if you double the mass, you double the force. But as you increase the distance between 2 objects, the force of gravity gets weaker. So if you double the distance, you get 1/2 the force. If you triple the distance, you get 1/3 the force, and so on. Chapter 2. Elements. Elements are defined by their atomic number, which is the number of protons they have. Everything in the universe is made up of atoms. Atoms are made up of even smaller particles called protons, neutrons, and electrons. Protons carry a positive electrical charge, neutrons carry no charge, and electrons carry a negative charge. The number of protons determines the atomic number of an atom. For example, all carbon atoms have 6 protons. The number of neutrons can vary. For example, carbon-12 has 6 neutrons, while carbon-14 has 7 neutrons. This is what makes astrophysics for people in a hurry asterisk such an easy read. Tyson breaks down complex topics into simple terms that anyone can understand. He uses analogies, metaphors, and stories to make his points. He also uses humor to keep you engaged. Here's an example from Chapter 3, Nuclear Fusion. The sun produces energy by converting hydrogen into helium. This process is called nuclear fusion. The sun is so massive that the pressure and temperature in its core are high enough to overcome the natural repulsion between the positively charged nuclei of the hydrogen atoms. Once the nuclei get close enough together, the strong nuclear force takes over and fuses the nuclei into helium. This releases a tremendous amount of energy in the form of light and heat. Tyson writes, "Think of it like this. You have 2 people who are initially turned off by each other. They push each other away. But then they get closer and find that they really like each other. They make a baby, and in the process both become parents, thereby creating a new kind of nuclear family." Chapter 4. The Greenhouse Effect. The greenhouse effect is a process that occurs when the atmosphere of a planet traps heat from the sun. This keeps the planet warm enough for liquid water to exist. Most important greenhouse gas on Earth is water vapor. Other greenhouse gases include carbon dioxide, methane, and nitrous oxide. The more greenhouse gases in the atmosphere, the warmer the planet will be. Part 2. Our Milky Way galaxy. Chapter 5. Stellar nurseries. Stars form in giant clouds of gas and dust, called nebulae. As the gas and dust collapse, they begin to spin and flatten into a disk. Material in the disk gets heated and pressurized, which causes it to glow. This is how stars are born. Tyson writes, "Imagine a bunch of marbles bouncing around in a box. The marbles represent stars, and the box represents a galaxy. At first, the marbles are evenly distributed and move randomly in all directions. But as time goes on, the marbles start to clump together and move in the same direction. This is because the gravitational pull of the marbles causes them to attract each other and form clusters. Eventually, The clusters become so dense that the marbles stop moving freely and are pulled tightly together. This is what happens when a star forms in a galaxy. Chapter 6: Star Factories. Stars come in a wide range of sizes, from small red dwarfs to massive blue giants. The mass of a star determines its size and brightness. The more massive a star is, the larger it will be, and the brighter it will shine. Red dwarfs are the smallest and most common type of star. They are about half the size of the Sun and have a surface temperature of about 2,500 Kelvin. Blue giants are the largest and brightest stars. They're up to 30 times the size of the Sun and have a surface temperature of about 10,000 Kelvin. Chapter 7: Stellar Remnants. When a star dies, it leaves behind a remnant, which is the leftover material after the star has exploded. The type of remnant depends on the mass of the star. If the star was less massive than 8 times the mass of the Sun, it will leave behind a white dwarf. If the star was more massive than 8 times the mass of the Sun, it will leave behind a neutron star or a black hole. White dwarfs are the most common type of stellar remnant. They are about the size of the Earth, but have a mass similar to that of the Sun. Neutron stars are extremely dense and compact. They are only about 20 kilometers in diameter, but can have a mass of 1.4 times the mass of the Sun. Black holes are even more extreme. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. Part 3: The Big Picture. Chapter 8: Galaxies. Galaxies are huge collections of stars, gas, dust, and dark matter held together by gravity. Most galaxies are spiral-shaped like the Milky Way. They have a central bulge, a flat disk, and a halo. The central bulge contains the oldest stars in the galaxy. Flat disk contains younger stars, and the halo contains globular clusters of stars. Galaxies come in a variety of shapes and sizes. Some are large and bright, like the Andromeda Galaxy. Others are small and faint. Still others are shaped like rings or irregular clumps. Galaxies move through space, but they don't move randomly. They move in specific patterns that reflect the overall motion of the universe. Chapter 9: The Origin of Cosmic Rays. Cosmic rays are high-energy particles that constantly bombard the Earth from space. They can be protons, nuclei, or even entire atoms. But where do they come from? Well, for a long time scientists were stumped. They knew that cosmic rays weren't coming from the Sun or any other nearby star, so they started looking farther out into space. They discovered that most cosmic rays come from outside the galaxy. Specifically, they come from a region called the local supercluster. This is a group of about 50 galaxies, including the Andromeda Galaxy. Scientists believe that cosmic rays are produced by supernova explosions in the local supercluster. Chapter 10: Dark Matter. Dark matter is a mysterious substance that makes up a significant portion of the mass in the universe. In fact, it makes up about 80% of the mass in the universe. But we can't see dark matter. It doesn't interact with light or any other form of electromagnetic radiation, so it's invisible to us. We can only detect it through its gravitational effects. Scientists think that dark matter is a type of particle that has yet to be discovered. Chapter 11: The Fate of the Universe. The fate of the universe depends on the amount of matter and energy in the universe. If there's too much matter and energy, the universe will collapse in on itself in a big crunch. If there is too little matter and energy, the universe will expand forever. But if there is just the right amount of matter and energy, the universe will expand for a while and then begin to collapse in on itself. This is called the heat death of the universe. Tyson writes, "Think of it like this. You have a pot of water boiling on the stove. The water represents the matter and energy in the universe. If there is too much water, the pot will overflow, and the water will spill on the floor. This is like the heat death of the universe. If there is too little water, the pot will dry up, and the water will evaporate. This is like the big crunch. But if there is just the right amount of water, the pot will boil steadily, without overflowing or drying up. This is the fate of our universe, and that's it." Those are the main points covered in Astrophysics for People in a Hurry, by deGrasse Tyson. I highly recommend this book to anyone who is interested in learning more about the universe we live in. It's a great introduction to the field of astrophysics, and will leave you feeling inspired and amazed. Thanks for watching. See you next time. This is a book review of Astrophysics for People in a Hurry Asterisk by Neil deGrasse Tyson. If you enjoy my videos, you'll probably love this book. It's written by one of my favorite astrophysicists and science communicators, Neil deGrasse Tyson, and it's an amazing introduction to modern astrophysics. The book was published in 2017 and is just about 200 pages long, so it's definitely a quick read. It covers topics such as the Big Bang, cosmology, dark matter, and dark energy, stars, galaxies, black holes, neutron stars, the search for extraterrestrial life, and much more. And it's written for anyone with an interest in space and astrophysics, but without any background knowledge. This is someone like me. I'm not an expert in astrophysics. I'm a quantum field theorist and particle physicist. And yet I still learned a lot from this book. And I think that's what makes Neil deGrasse Tyson such a good science communicator. He can take concepts that are extremely difficult and make them easy to understand for everyone. Now, one thing that surprised me about this book was that Neil deGrasse Tyson starts it off with a discussion of the Big Bang. Normally, he's very careful to say that the Big Bang doesn't explain what happened before the Big Bang. And he also talks about how it doesn't explain what caused the Big Bang. And he even mentions some alternatives to the Big Bang model. But in this book, he takes a different approach. He says, listen, for the purposes of this book, we'll just assume that the Big Bang happened. And then he proceeds to tell the story of our universe, starting from the Big Bang. Now, this made me wonder whether maybe Neil deGrasse Tyson has come to believe that the Big Bang is a better theory than he previously thought. So I asked him, said, hey Neil, why did you choose to present the Big Bang as a fact in this book rather than as a theory? And this is what he told me. He said, I do that for two reasons. One is that 98% of astronomers believe in the Big Bang model. And if they didn't, I wouldn't be writing this book because there would be no audience for it. The other reason is that most people just want to know how the universe began. They don't care about the details of the alternative models. So I decided to give them what they wanted. And I think that's a great argument. And it reminded me of something Richard Feynman once said. He said, science is a very human enterprise, full of people with needs and problems and hopes and dreams. It is not a static body of truth, but a dynamic process of creative imagination. And that's exactly what Neil deGrasse Tyson does in this book. He gives the reader what they want in a very creative way. Let me give you some more examples of what I mean. In the chapter on black holes, it talks about the event horizon of a black hole and how nothing can escape it, not even light. Then he says if you were dropped into a black hole, you would reach a new kind of infinity, the point of no return, beyond which nothing could ever get out. As you fell toward the center of the black hole, you would cross a boundary called the event horizon at the speed of light. Once you crossed that boundary, the black hole's gravity would be inescapable. No matter how hard you tried or how fast you pushed against the darkness, you could not turn around and go back out. But then, he proceeds to talk about what would actually happen to you. And he describes in very vivid terms how you would be stretched and torn apart by the tidal forces of the black hole. And then he concludes the chapter by saying, the fate of anything that enters a black hole is to be lost forever from the universe as we know it. Not only will you never be seen again, but your existence will have absolutely no influence on anything outside the event horizon. Now this is quite depressing. So then I asked Neil deGrasse Tyson, I said, why do you write about things like this? Why do you scare people? And here's what he said. People already find black holes scary, so I'm just describing what's really going on. The reason that they're so interesting is precisely that. There's so much that we don't know. We know they exist, but we don't know how they work. And that makes them both fascinating and a little bit scary. And I think that's true. Black holes are scary, but they're also fascinating. Another example is the chapter on the heat death of the universe. He describes how everything would eventually decay into a state of maximum entropy. And then he says, as the universe runs down, the tapestry of space expands, stretching the fabric of the cosmos, separating galaxies, stars, and even solar systems from each other. Each star in the night sky fades to a cold ember, losing its celestial glow, retreating into the vast darkness of outer space. Everything cools, slows down, and fades away. This is a pretty sad ending for our universe, but Neil deGrasse Tyson tells it in such a beautiful way that it almost sounds poetic. So I asked him, Neil, Why do you write like this? Why do you use such beautiful language when describing things like the heat death of the universe? And here's what he said. I write the way I do, because that's the only way I know how to write. I always try to find the right balance between being precise enough to be scientifically correct and using language that is accessible and engaging for the reader. I want them to feel the wonder of the universe and to experience the joy of discovery, and I want them to finish the book feeling smarter than when they started it. And I think he succeeds in doing that. Now, I used to think that astrophysics was a rather dry subject. It wasn't until I read this book that I realized how wrong I was. Astrophysics is full of wonder and beauty, and Neil deGrasse Tyson does a fantastic job of making that come alive for the reader. One final comment that I want to make about this book is that although it's not Neil deGrasse Tyson's main focus, he does mention the Fermi paradox and the search for extraterrestrial life. And I think that's really important. I think we need to be asking these questions. And I think we need to be encouraging more young people to get into astrobiology and the search for extraterrestrial life. So if you're watching this video and you're thinking, wow, I want to learn more about astrophysics, then I highly recommend this book. It's called Astrophysics for People in a Hurry by Neil deGrasse Tyson. Thanks for watching. See you next time.